¿Cómo están? And that's all the Spanish you're going to hear from me. Welcome to writing object-oriented JavaScript with TypeScript, and I'll do it in VS Code. I'm Rachel. Today we will look at TypeScript as a language, the TypeScript overview, some features, using it with the VS Code editor, a little bit about types themselves, being that it is TypeScript, and then also creating our object model to write object-oriented JavaScript without having to write in JavaScript. That's probably the best part about writing in JavaScript, is that you don't have to write in JavaScript when you use TypeScript. So for TypeScript, it's all about the types, hence the name TypeScript. There had been a problem with JavaScript, more than a problem in JavaScript. One of the things that are very good and very bad about JavaScript are the lack of types. Sure, JavaScript will let you do anything, but you know what happens when you let a programmer do anything? They will, and it doesn't end well. So we like to write JavaScript because of its flexibility. However, programmers like to get into trouble that way. Yeah, I know, I do it all the time. Well, one of the things that cause us to get into trouble are the types. So TypeScript came out as a way to help aid with using types and programming in a more constructive way. So it should help us with those things. Some of the features of TypeScript 2, as you see on the slide, things like non-nullable types, a never type, module types, type acquisition and declarations, new things like private constructors and optional properties. So a lot of great first-class programming features are in TypeScript. One other reason for TypeScript is the fact that many of us were C# or even VB.NET. We have VB.NET people here? Willing to admit it as well. Yeah. So C# and VB.NET people, we're very used to the .NET framework and a compiler telling you when you do things incorrectly or when you might cause a problem. JavaScript doesn't do that though. JavaScript just lets you do anything. And then again, we do, and bad things happen. So TypeScript helps keep us under a little bit of control. Instead of giving us a compiler, what it does is it gives us a transpiler. It's basically a compiler that just compiles TypeScript to JavaScript, where a normal compiler compiles your high-level language into something lower level, like a bytecode or CLI for .NET or something like that. So it's very similar. All you really need for TypeScript is the transpiler, and it's tsc.exe, so you could call that and pass any TypeScript file or files to it, and it will create JavaScript for you. There's the link for the compiler options. There are many. You can also do a help flag at the command line as well. As far as a TypeScript program goes, oh, and back to the compiler quickly. You only need this compiler and Notepad. I know there's someone in here who's like, Notepad! At least one. There's one in every room. So for you, that person, you don't like VS Code or IntelliSense or color coding or anything, actually, then go ahead with Notepad. Yeah. So a TypeScript program. It's kind of like other programs. We have modules. All right. Oh, that's that's a little better. I'm getting some, can you hear like a chimey, all right, it's not just me. This is off. Off, on, no. Am I just yelling that? I can just yell really loud, that doesn't matter. I have a big mouth. So for a TypeScript program, it's made up of modules, not unlike .NET. Right? So you have modules in .NET and namespaces. And we have that in TypeScript as well. So you may have one or more modules, and you can have those modules available to other modules or programs. And inside of those, we can have classes. Now, if you see that word class, that's not a word that shows up in JavaScript. There is no classes. There's no types. There's a lot of nothing in JavaScript. It's just a void wasteland of code. So we can make classes, though. And if you've made a class in JavaScript, it is really, at its barest level, just a function. Literally everything in JavaScript comes down to being a function. But it's the way that you syntactically set up that function is what makes it kind of a pain, a big pain in the butt. So TypeScript will alleviate that pain, because you can't just simply go and make a class easily in JavaScript. Right? You need to go and use a pattern, like a module pattern or something like that. And there's a lot of details in the syntax, which makes it look very ugly as well. So we can have classes, and we'll actually even be able to use a class keyword to get that. As you might expect, properties, methods, and other members show up in classes. We don't usually use these words in JavaScript, but we can now if we use TypeScript. So TypeScript is taking C# developers and allowing us to just easily transfer our skills over to the JavaScript world. How we get types, they're not magic. Since TypeScript is a superset of JavaScript, it's just nicer to write JavaScript. We do need those types. So one way to get it is the definitely typed repository. There's an older one, if you've played around with TypeScript 1, called TSDs. They're going away. But there's also a typings registry and @types for NPM. So if you're doing Node with TypeScript, that's fine too. Here's where you can get all of those, all off of GitHub, of course. Now in VS Code, if I want to go ahead and set up my compiler, and you can also use Visual Studio proper as well. What I need to do in Visual Studio Code, if I'm using that, is come in and do a Control-Shift-P, and I could come in here and start typing in the word TypeScript. I can also set up what are called tasks. If I go into code and type in tasks, I can then configure the task runner and the build stuff that I need. All that does is set up a JSON file called tsconfig, and it just tells me, hey, I'm going to run TSC for you. That's what VS Code is doing. So when it does that, how is it going to do that? What compiler flags is it going to use? So here, what modules do I want? We'll see source map in a bit. Allow JavaScript. You definitely want that to be true. Since TypeScript is a superset of JavaScript, yeah, we can mix and match. You could put regular old JavaScript in there, in with your TypeScript. It all ends up being JavaScript in the end anyway. And then also your target. So that may be important depending on what you are writing. So ES5, I can target that. When I use VS Code, it also sets up, so I cannot escape this little sound here. Maybe that's better. There's a hidden microphone here.
Okay. That's fine now. I think it was muted.
Oh, so that, okay, not even on. It's just the magic microphone. Oh, this is much better. Okay. No, I don't. These are not on. This is just a, yeah. Something's haunted. That's what it is. That's what I say every time it doesn't compile. It's haunted. Here in VS Code also, I can set up more JSON files, such as this one, right, with my version and the path to where TypeScript is. Now, you do all this when you do a Control-Shift-P and say, set up my tasks. And that's all you need to do. If you're using regular Visual Studio, no problem. You can download the Web Essentials and it shows up in there. It is still chiming at me. Your microphone hates me. What? I don't know what this is. I mean, you can turn it off. I could yell. That's not a problem. No.
You have something.
Yeah, they're not on though. It's just they're actually out of juice. All right, so the types in TypeScript. Of course, as you might expect, there's primitives, strings and numbers and dates and things like that. And then we have this object called any. And any is basically the equivalent of .NET's system.object, right? Except we call it any. Everything in TypeScript derives from any. So everything is an any type at some point. We also get undefined, void, object. One of my favorites, oh, this should have been in JavaScript, HTML element. Now, if that showed up in JavaScript 10 years ago, we might not even be talking about this. Dealing with that. That one's an easy one. Enums, handy little things. Of course, functions. There's also a never type. I like that. Never be this type. Be any other type. We tend to use that with special use cases when you're throwing an exception and you just don't want certain types to be returned. Nulls as well. Null, void, and undefined. So we get those now as special types we can declare, and it will create those in JavaScript for us. So there's some of the standard types. They also have tuples and some other types as well, but these are very popular and things that we tend to use in other languages. If we want to declare a type in code, var, because we do that in JavaScript, the var keyword. But also, VB people will appreciate this. If you're old VB, like VB6 and before, anybody else here that old? Yeah, not just me. Woo, old people. Let, the let keyword. A few other languages have this as well. So we could do either or, var or let, does not matter. You also get the public and the private and protected and those keywords too. But just for a local, var or let. So if I want to say any type, I could say let. And in this case, let some variable called not sure. I'm going to assign it as any type. And I'm going to cram a number in there, 4. Okay, so it lets me do that. Then I can assign it to a string. That's okay, because it's any type. So it's basically just JavaScript with extra crap now. That's all that it is. Because this is what JavaScript does, and you don't need to do anything at all. However, if I go and assign it to false, that's fine too, even though that's definitely a Boolean instead of a string or a number. So any type is the same as not declaring a type at all. And again, everything derives from any, the built-ins, and your own types. You can set types to anything, to arguments and parameters of functions, to return types, and you can even allow TypeScript to produce JavaScript that does type inference, which is what JavaScript does, except it seems to always get it wrong when JavaScript does it. All right, I meant this type, it used another. Well, now TypeScript will help us solve that. I could set things to Booleans. This is pretty standard issue programming. Everybody's seen a Boolean. So I can have a Boolean or an array, and this code here should behave exactly in any language how people would expect it to. If I want to set up an enum, I can just use the enum keyword. So I like this. If you wanted to set an enum in JavaScript, it's a pain. It's just a lot of extra coding. It's certainly more than 2 lines of code to do it in JavaScript proper. So I have my color enum keyword, the name of it, and in brackets, my items. Then I can use dot notation with the let or the var to go ahead and assign that type, the color enum type, to this variable C, and then set it to one of those items in that type. We get interfaces, since it's an object-oriented deal. Interface keyword, again, much easier than in JavaScript itself. And this looks almost identical to C#. Right? Interface, the name, and then whatever members that you have, and the types, and then I could go ahead and just use that interface somewhere. If I do tuples, that's fine, or tuples, depending on how you want to argue to pronounce that. Kind of like GIF or GIF, nobody knows. Same thing here. When I declare a tuple, so a tuple is an array, but the array can have whatever kind of types you want, mix and match types. So here I can have X that can contain a string and a number, and then go ahead and initialize it like you would a regular array, but we just have mixed types. You can use your dot notation and your square parens, square brackets to access those members. Null and undefined, of course null means unknown. We don't know what the value of something is. Undefined means it just hasn't been set yet. So a slight difference between those two, but that's what the difference is. Null, we just don't know what the value is. Undefined is that we hadn't done it yet. For voids, we could let things be a void. Very similar to the other ones as well. We use voids generally in a return. All right, so if we want to return nothing, we don't care about the value, we'll just void it out. There's that never type again. Never type comes up with a lot of rules around it because it is a bit of an oddball. It's a subtype of and assignable to any of the types. So you could say never be this type, never be that type, but no type can be a subtype of never, which makes sense, I think. Right? Depends on what you want to do, I guess. Except never itself. So never can be never. Always. Something. Any, you can't assign any to never either. So never is just a very edge case type. We can also do assertions, or what I call diet casting, right? So casting on a diet. So here, I could use the parens, or not parens, brackets, or the as keyword. So here I have a number, but I am asserting it to be a string, or the other way around, a string, and I am asserting it to be a number. Here on the bottom, I have another one that I'm asserting as well as a string instead. So we can change it, and the as keyword is also something we can use in C# as well. We also have what's called a type alias. This is a bit like the tuple in that I can pick out a few types that I want to work with and say this variable can be of this type or of that type. So in this case, I have something called string or number, and I'm actually going to use the keyword type. Say type, string or number, and then string or, with the pipe, number. And then I can set it to a string, I could set it to a number, but I can't set it to anything else. But I do get that choice. You like how this is evolving? We go from JavaScript, where anything could be any type, but it's no type at all. So you can just change the types very fluidly. And then we go to a strongly typed language like C#, and then each type has to be its own type, or a derivative of it. However, this little middle ground now exists where I can say, hey, this could be either of these types, which I think is very flexible, because you do have to write a lot more code in any language that does not allow this to have something like this happen. As you might expect, read-only as well. You could do read-only stuff, so that's fine. Just use the read-only keyword. And again, notice all these keywords that are going to show up. We don't have these keywords in JavaScript. Right? JavaScript just doesn't like that, but we do now. So I can just say read-only and make those members read-only. So let's take a little look here in VS Code. Now this is a very lightweight model and view, very, very small. And how it works in TypeScript, I will use a .ts file, and I will write my code in there. So in here, my sample is going to be a banking sample, and you will find out why I don't work at the bank in a second. Because this is what the whole user interface for the bank would look like if I wrote it. All right, not a UI person. So here, if I want to open an account, I can put in my name, some amount that I want to start with, and what kind of account. I can open it up, looks good. And now that I have some information, I can then keep depositing money. I like that. That's never how it goes, though. It always goes the other way. And then I can also take out or withdraw some money. Seems to work. If I try to withdraw too much, it yells. All right. So kind of how a bank would work, except more yelling and charging fees seems to be what they like to do. So here, if I were to set this up with an OOP model, I would have my module. So I called it Bank of TypeScript. And of course, like I just said, banks like to charge you money. I can never understand this. If you don't have any money in your account, they charge you more money. Where do you think I have money if you're... It doesn't work that way. If I had money in the account, then that would be fine. Why are you charging me if I don't have money? That's weird. But that's what they do. So here, I might set up an interface to charge people fees for money they don't have, because that makes sense. So I would make it an interface with the interface keyword, and then the name of my interface, and the signature of how that method should look. All right, so charge fee takes a number, returns a number. I like the number type, very easy. I don't have to specify what kind of number, just that it is one. By using the export keyword, that allows other modules outside of this one to be able to use that member. So here's my class. Well, that's much nicer looking than in JavaScript already. Right? Class bank account. Here I have a constructor. That's not what a constructor looks like in JavaScript. They look stupid in JavaScript. Same thing here. The account type, or the account holder name, the balance. Very nice. A private member, and then public members. In this case, if I just do a get without a set, that would also give me a read-only, but you can mark it with the read-only keyword as well. The balance, right? There's my charge fee from the interface, account ID. So this looks very similar to C#. If you know object-oriented concepts, and you can just basically read object-oriented code, this is not difficult at all to follow. But what this looks like, all of this in JavaScript, and I'll just scroll to the bottom quick so we can see there's nothing terribly fancy in here. Here's my open account, right? It sets up those properties. And also some derivatives. We'll see those in a second. Savings account, investment, checking. Right? Just standard business code here. If I look at what happens with this in JavaScript, this is what it looks like. This pile of nonsense. But you need to do stuff like this. Not necessarily with the same member names and whatnot, but you need to go and wrap up everything in patterns. You need, say, a module revealing pattern or one of those kind of patterns to go ahead and properly do encapsulation and to properly make what would be the equivalent of a namespace or the equivalent of a class or a member. So the way we would do that in JavaScript is a variable for that type or namespace, and then a function because everything's a function. And you'll notice right away it's doing the jQuery ready function notation. That's how they work in there as well, by using these kind of patterns. Here's the constructor. All right, looks like that's not terrible, but this annoys me. Right? There's something to be said about syntactic sugar and good-looking code. When I have to do this for, say, the bank account type, and I need to say object, define property, bank account, prototype, and then have a get, and then do it again, and with a get and a set, right, for the account holder, it's a little ugly, quite frankly. And if you're looking at code, as programmers scan through code, your eyes get a little bit jarred if the code looks a little stupid. And it does, right? A lot of JavaScript ends up that way because it wasn't meant to do this. What JavaScript was meant to do was to work with HTML pages in 1995 that ran on Netscape Navigator, right? For those of us old enough to have used that thing, right? That's what it was there for. When the document object model was not a gigantic tree, it was a little sapling with 3 branches. And one of them was the blink tag. We had like 6 HTML tags. That was what it was made for. And over the past few decades, it's turned into a monstrosity. I was saying the other day in the workshop, like, did anybody a few years ago would have laughed and said, JavaScript on the server, JavaScript everywhere, it'll never happen. Yeah, it never happened. As in, it's always happening. So, same thing here. And I keep going. I could keep going through all of this JavaScript. And then, see, you have the patterns. You forget a bracket, or you forget to close your parentheses and tell it auto-run with the parens. You have a bug, and there's no compiler to warn you in JavaScript. You have to wait until you run it, and then you might not get an error. And quite frankly, I would rather an error that I can go and Google than not having an error and trying to dig up where the source is. Same thing here, trying to do some inheritance. Oh, look at that code. Like, who wants to be reading that? All right, that would give you a headache every day. All right, this is the code you write the day before you're quitting your job to leave for the other person, right? If you don't like them, that's what that code is for. All right, so and that's what it likes. So instead, we could write code that actually looks like normal code. Right? If I'm working strictly with the DOM and an HTML HTML page, JavaScript looks kind of normal. But if I move over and want to use it in, say, a spa application or something like that, JavaScript does not look normal anymore, because it's not, right? It wasn't meant for that. But we are programmers, and we will fit square pegs into round holes where we can. Now with this, when I go to deploy this, I can't just deploy a TS file. What I need to do, because the browsers, Chrome, IE, any of those things that can run a script host, they don't run TypeScript, they run JavaScript, right? And we see that TypeScript compiles into JavaScript. So what we would do is write in TypeScript and then send the JavaScript off to be included as in the script tag in an HTML page. Now in this case, I just made this small TS file for the bank account, but I do have that HTML page. And this is a very small DOM. I even still use tables once in a while. Look at that. That's swimming upstream in 2017 instead of div tags. But here's a TS file to work with that. So I don't even have to use TypeScript just for the OOP stuff. I can also use it to get those DOM elements as well. So here when I click the Open Account button, right, and here I just put it all in a window on load, right, grabbed the buttons and put them in variables, right, with a good old get element by ID. That still works, right? And because remember, this is JavaScript, so I'm just grabbing those and sticking those in a couple of variables. Then when I do the account open, now I'm grabbing these and converting them to an actual HTML input element. Right, doing the get element by ID and grabbing its value out of there. And I could do the text boxes and the drop downs, as well as others with options. A little error if we don't do the account type. So here, I can work with the DOM elements as well. So you don't have to go back and forth between TypeScript and JavaScript. You can just do it all in TypeScript. And when I do want to use it in HTML, again, if I go back to my HTML page, in here, I just reference my JavaScript files. Right, so my user interface one to work with the buttons and the text boxes, and then my model, my little model to work with the data. So then this way, as I come in here and interact, it's TypeScript in the UI, TypeScript as well in the back end, if you will, right? The tiny back end that we have for this demo. Now again, because I deploy JavaScript, there could be an issue with debugging. So if I deploy this, and run this, and there's a bug, we like to do things like step through code and stuff like that. Well, you could do that. How we do that is by allowing TypeScript to make what's called a source mapping. And you may have noticed these little map files. They come automatically, and all it is one giant piece of JSON with weird stuff in it. And all it's doing is taking the TypeScript blocks of code and marrying them to the JavaScript blocks of code. So as long as you have this map, you are good. And you could set up this map with that source map equal true in here. And in Visual Studio, when you go into Tools and Options, and you go into the TypeScript options, you'll see the same thing. Check off, yes, source maps. They're on by default because we like debugging. Then you could use F12, and it'll actually pull in TypeScript and look at that. So that's pretty cool that we do that. So some of the things that you'll see, I just showed Ian VS Code itself. All right, class is a class keyword. Methods just look, I like the top better than the bottom. Right, that looks nicer to me. Inheritance, you could just extend with the extends keyword. Again, to me, the top looks nicer, easier to maintain. If you have a junior programmer, that's going to be way easier than on the bottom. Same thing, classes. We get public and private and protected, right? So I get to use all of those. And look at this. It looks very much like C#. The only difference being that we do a little colon and then the type name. So just a different location for the type name, but it's the same thing. And again, you could do the get element by IDs and work with TypeScript the same way that you normally would. All right, so, ooh, I was getting the 5-minute warning back there. But as you see, TypeScript makes it really easy. I write in code that looks very similar to C# and has many of those same features, but it converts it to JavaScript for me. Unlike historical Microsoft products where they would do code generation and it would generate so much stuff that it was kind of ridiculous. No, TypeScript actually generates the JavaScript you should write if you were writing this in pure JavaScript. You don't get extra crap like you would have in some of our earlier products that did code generation. So that's one thing. Another thing with your tools, Visual Studio or VS Code. All I need to do is make a change in here. So at any time I'll just copy and paste quick, and I'll just call it test, because that's what programmers name things, right? Test. And then I will do a build, a Control-Shift-B. In Visual Studio, you can even have it do it when you save it. So I've changed my TS file. If I open my JS file, you see it shows right up in here. And that's what it now looks like. All right, so it just made this quick little method right here for me. So that's all you have to do is write it, and when you build, it creates the JavaScript. If at any time you don't like the JavaScript, just delete it, blow it away, and it'll recreate a new one. You can modify this JavaScript and then take it aside off on its own. You might, if you do modify it, there is a potential to overwrite it. Just be aware of that. But you can still take the end product and then use that somewhere. The other benefit too is because this works so much like C#, large teams doing full JavaScript applications, full client-side stuff, that's going to make it a lot easier to manage these files in Visual Studio or VS Code, because instead of having to deal with all the ways that JavaScript loads up and deals with itself, it behaves more like C#. So it integrates better with the tools. You can build and you could get the compiler warnings and whatnot right away instead of waiting until runtime. So those are some of the best features, I think, of TypeScript. And now I'm totally told axe time, right? I talk too much. So that should get you a nice intro to TypeScript. You should be able to at least start writing a little bit of code in it. And I think everybody will enjoy it. If you haven't seen it yet, I certainly suggest it, especially for large enterprise teams. So thank you.